All right, in this video here, we are covering the double angle formulas. So take notes. Hopefully you're keeping up with the assignments and you are checking in for attendance. Okay. Oh, that's not the one that I like. Okay, so 5.3, double angle formulas. So you should have access to the formula sheet. Feel free to use that when you are taking your quiz and your test. Okay, it has all of these that we are looking at. It might have a few more as well, but it has like the sum and difference formulas that we covered in the previous section, and then the double angle formulas here, and then the next section, which has the half angle formulas. Okay. All right, so double angle. So now we are dealing with 2 times some angle A. Okay, so we'll look at sine of 2A, cosine of 2A, and tangent of 2A. All right, so sine of 2A is equal to 2 sine A cosine A. Okay, so this is your double angle formula for sine. Okay, and we'll do the proof of each one so you can see where they come from. All right, so we know that sine of 2A is the same thing as saying sine of A plus A, right? And we know from the previous section that here, when we have the sum of 2 angles, then we can use the sum formula. So this would be sine A cosine A plus cosine A sine A, because the B here is actually A. Okay. So here it's commutative, so I can go ahead and switch the order here. So I have sine A cosine A plus sine A cosine A. And so we can see here that, oh, okay, well, we just have 2 of these. So 1 plus 1 is 2. So we have 2 sine A cosine A. Okay, so that checks. All right, so that's our double angle formula for sine. Let's take a look at cosine 2A. So here, and we actually have 3 choices. So we'll look at, here is the first one. Okay, so let's do this. Cosine 2A, which equals cosine squared A minus sine squared A. So this is one of them, one of your options for cosine 2A. Let's do the proof here. All right, so we know that cosine 2A is the same thing as saying cosine of A plus A. And then using the sum formula from the previous section, this is equal to cosine A minus sine A sine A. Again, it's because the B here is actually A. Okay. And this gives us cosine squared A minus sine squared A. Okay, so this one checks. Let's take a look at the second version, okay, or the second option for cosine 2A. So depending on what information you're given, you will decide which of the 3 options to use for cosine 2A. All right, so clearly here, if you have cosine and sine, you can use this one. In the second option, cosine 2A is equal to 2 cosine squared A minus 1. And so if you're only given cosine, then you would choose this option. All right, let's take a look at the proof of this one. Okay, so here cosine 2a is equal to cosine squared a minus sine squared a. That's from up above, right? So we already know, and we have proven that cosine 2a equals this. So we're going to use that. Cosine 2a equals to this. And then I'm going to go ahead and replace sine squared with 1 minus cosine squared. That's one of our Pythagorean identities, right? And so we get cosine squared a minus 1 plus cosine squared a. And then I'll combine the two cosine squares. And that's what I get. Okay, so we verified this. And then the third option is very similar to this second one, except that instead of cosine squared, you have sine squared. So 1 minus 2 sine squared. And so this one you would use if you are only given sine. Okay. So let's do the proof here. So we know cosine 2a, again, is equal to cosine squared a minus sine squared a. And then here, instead of replacing the sine squared, like I did in the second one, I'm going to replace the cosine squared with 1 minus sine squared from the Pythagorean identities. And then here we see that -1 and -1 is -2. So I have 1 minus 2 sine squared a. Okay, so that one is verified. Okay, so we're going to wait until the last video to look at tangent to theta. Okay, so let's just take a look at some examples now of working with sine 2a and cosine 2a. All right, so let's take a look at this example here. If sine A equals 3 over 5 with A in quadrant 2, find sine 2A. Okay? All right, so we already know, I'm going to be drawing this here. It's in quadrant 2. It's always helpful to draw things out so that you end up with the correct signs at the end. All right, and we know that sine of 2a is equal to 2 sine a cosine a. And so far, I can plug in for sine a. Sine a is 3 over 5, but I don't know what cosine a is, so I can't fill this in just yet. Okay, so I'm going to go ahead and draw this triangle out. Okay, so here we have our perpendicular, and we know the sine of this angle is opposite 3, hypotenuse 5. And then if I do Pythagorean to find this missing side over here, I can do 3 squared plus a squared, or if you want to call it b squared, that's fine. Doesn't matter. Equals 5 squared. 9 plus b squared equals 25. If you don't know it's 4 already, maybe we haven't done enough of these. Okay, b equals 4. All right, but here, the x value here, x values are positive here, x values are negative here. So this is not going to be positive 4, it will be negative 4. Okay, so here, if I take a look at what cosine is, cosine will be adjacent over hypotenuse. So that's going to be -4 over 5. So now when I multiply this all out, I get -24 over +25. Okay. So this is why it's helpful to draw, especially when they start talking about, oh, this angle is in quadrant 2. This angle is in quadrant 4. Okay, so when they start mentioning that kind of stuff, you definitely want to draw out your quadrants and draw where your angle is landing. Okay, That way you get the correct sign, like right here, -4. All right, let's take a look at another one. If cosine A equals -3/8 with A in quadrant 3, find sine 2A. Okay, so we are in quadrant 3, so we're somewhere in here, and we know that sine 2A is 2 sine A cosine A. I don't know what sine A is, so I can't fill in there. Cosine A is -3/8. All right, so uh, let's go ahead and fill this in. Since we know cosine is adjacent, so that's going to be -3 over hypotenuse, so that's going to be 8. And then I have -3 squared plus b squared equals 8 squared. 9 plus b squared equals 64. And b squared equals 55. And then b equals square root 55. Okay. But again, over here, y values are positive up here. Y values are negative here. So this distance here is going to be negative square root 55. Okay? All right, so sine is opposite over hypotenuse, so that's negative square root 55 over 8. And then when I multiply this, I can cancel this out there, make it smaller. And I get positive 3, because double negative. 3 times square root 55 in the numerator, 4 times 8, 32 in the denominator. Okay? All right. Let's take a look at another example here. If sine A equals 1 over square root 5, find cosine 2A. All right, so let's just recall that we have 3 choices. 3 choices for cosine 2A. All right, so we can use our first choice, which is cosine squared A minus sine squared A. We can use our second choice, which is 2 cosine squared A minus 1. Or we could use our third choice, 1 minus 2 sine squared A. Okay, so we have our 3 choices for cosine 2A. Since I only have sine A, then I'm going to use not that one, not that one. I will use the third one because the other 2 require that I have cosine, which I do not have. Okay. All right, so I'm going to use the last one, 1 minus 2 sine squared A. So 1 minus 2, sine A is 1 over square root 5, and we're going to square that. So we get 1 minus 2 times 1 squared is 1, square root 5 squared is 5. So we get 1 minus 2 over 5. I'm going to change that 1 to a 5 over 5. And we get 3 over 5. Okay. All right. Why don't you try this one? Why don't you try this? All right. If cosine x equals -3 over 4, find cosine 2x. Okay, so you try to figure out which of the 3 you are going to use here. Okay, go ahead and hit the pause button, work it out, and come right back. Okay, so here, if I need to find cosine 2x. And I have three choices. I could use the first formula, the second formula, or the third formula. Since I'm only given cosine, I am going to use the second formula, this one right over here, since the first formula and the third formula require that I have sine, which I don't. Okay. All right, so we're using the second one, 2 cosine squared a minus 1. So cosine 2x is equal to 2 cosine squared x minus 1. So this is the one that we are using. All right. All right, so cosine 2x is equal to 2 times cosine squared, so negative 3/4 squared minus 1. So that's going to be 2 times 9 over 16 minus 1. 2 and the 16 cancel out. 9 over 8 minus 1. And then I get 9 over 8. Change that 1 to 8 over 8. And I get 1 over 8. You should have gotten 1 over 8. Okay? All right. So that's it for the first video. In the next one, we're going to take a look at proving some identities here using the formulas that we have learned in the last two sections. Okay?